All right, so I've already gone ahead and loaded my exam data into Minitab, and this time I changed my zeros to blanks ahead of time. So let's run a few linear regression tests on this. The first one I wanted to do was to use just look at exam 1 and exam 2. So plotting exam 1 on the x-axis and exam 2 on a y-axis. Let's see how nice a pattern we have. And if we know the pattern, the kind of thing that will let us do is look at this student down here in row 8. They got a 38 on exam 1, and then they missed exam 2. And they also had missed exam 3 and 4, so they probably just stopped showing up. But if they only missed exam 2, we could use the pattern, if it's a strong pattern, if the dots really look like they appear in a line, we could use that pattern to guess what they might have gotten on exam 2, because we see what all the other students did on exam 2 based on their exam 1 grade. So how do we run the linear regression test? Well, so we go stat and then regression. There's lots of types of regression. We are going to do fitted line plot, because that's what we're going to do. We're going to plot all the points and find a line which most closely fits with the dots. Okay, so here's exam 1 to exam 4. I don't know why it has the y first and then the x first, but the x coordinate, I said that that would be exam 1. We're going to use their exam 1 score to predict the exam 2 score for the students who we don't know. That's why this one's called the predictor. And response, it's sort of like question and response. You have the question first and the response after. So the response is the second thing that comes. That's going to be our exam 2. So exam 1 is going to be on the x-axis, exam 2 is on the y-axis. If we know the exam 1 score, we can make a guess at the exam 2 score. This one allows for different types of regression. If we don't want a straight line shape, it does try to fit a quadratic or a cubic to the shape, but we're only going to be doing linear regression. Graphs, there's a bunch of stuff we can put on the graphs. We're just going to use the standard default graphs here. Residuals are sort of how far away each point is from the line. So they have like all this different stuff about like looking to see how far away the dots are from the line, graphs of sort of those differences. Options, these weren't checked off by default. I've gone ahead and checked these two display options, confidence interval and prediction interval, and 95% confidence interval is the default. What do these mean? I'll talk about that once we get a graph. And then the storage stuff, I don't really do that stuff here. Okay, so exam 1 in the x, exam 2 in the y, linear regression, and basically the defaults, except that I actually did check these two interval display things. Okay, let's see what we get. All right, so here's our regression equation. This is an equation of the line. So the y coordinates are exam 2, the x coordinates exam 1. So a line is normally y equals mx plus b. So the number multiplying the x is this 0.7895. That's your slope. And the number that's not multiplying the x, 2.327, that's the b, the y-intercept. So this is the equation of the line. These numbers here, they're sort of a measurement of how accurately the dots fit the line. So let's go down and look at our picture. And you can see that these dots don't really look like they're going in a line. If this red line wasn't there, we'd see like sort of a blob where I suppose that as you sort of move to higher exam 1 scores, the exam 2 score gets a little bit higher, but there's plenty of people with high exam 1 scores and low exam 2 scores. Like the people with low exam 2 score, like, there was a lot of exam 2 scores sort of in the middle here in the 20s and 30s, and it didn't matter how well you did in exam 1. These dots do not look like they're in a line. There's a slight upward trend, but not a very strong one. So these numbers here, particularly the R-SQ, that's R squared, they measure sort of how well the dots fit the line pattern. 33% is not good. If these dots looked like they were really in a line, this number would be like 90, 95%. 33% is really low. It's low enough that you're basically saying this isn't a very good pattern. Okay, so we do have a little bit of an association. If we wanted to guess someone's exam 2 score, like guessing it based off of their exam 1 score would be slightly more accurate, but only a tiny more accurate than just guessing that they would get the same as the average exam 2 student. Exam 1 isn't going to help us guess that much. So this person who got a 34 in exam 1, the way we would guess their exam 2 score is plug in 34 in the exam 1 slot, multiply by 0.7895, and add on 2.32. And that would give us our guess for their exam 2. Would be a very good guess, but like I said, it would be better than just guessing that they would get average. So the red line is the graph of this line that we have up here. That's the line that Minitab is computed to be the closest to going through the dots. This dashed line just above and below, that is sort of a range where we think that the mean might be for each exam 1 score. So like for all the people who got 45 on exam 1, what do we think that their mean would be on exam 2? And we think that it would be somewhere between those two dashed lines. Okay, and like for all the people who got a perfect 50 on exam 1, where do we think the mean would be on exam 2? It would be somewhere between those two dashed lines. So it's kind of like a 95% confidence interval, but just limited to a single exam 1 score. And presumably the higher the exam 1 score, the higher that interval would be. The dotted lines are trying to capture all of the scores, not just the average for each particular exam 1, but all of the dots. We want 95% of all of the dots to be in here. And there's only 2 dots that appear outside of those lines. This one person who got a perfect on exam 1 and only 23 out of 50 on exam 2, that's pretty unusual. And this person who got a 43 on exam 1 and a 20 on exam 2, that's also very unusual. Everybody else ended up between these 2 other lines. So we have 2 sets of lines. The outer lines are supposed to get 95% of all the dots. This narrower gap of dashed lines are supposed to be where we expect the mean to be on exam 2 for each particular exam 1 score. So when I ask you a question based on linear regression, you need to get your data into Minitab down here, but then the type of things that I would ask you for are this equation, for example. I might say, if someone's exam score was like a 43, what do we think that we get on exam 2? And you just plug it into this equation. And I would also ask for this R squared value, this measurement of how much we can trust the guess, how good of a guess it is based on how well all the other students follow the pattern. Okay, so let's do this again for a couple different exams in a separate video.